Hey everyone, welcome to the final part of the Cytotoxic build log. I'm going to start this video by completing the mods. I need to finish the side panel mods and also the reinforcements for the water cooling loops. I'm then going to move on to the performance and temperature results, and finally a good look around the finished product. As I mentioned, I am still going to show how I pack up my systems for shipping, but I'm going to cover that in a separate video. In the last video, I mentioned that what I have in mind for the side panels is to basically make two new side panels to go over the top of the old ones. So I've cut out the windowed side panel, and as you can see, I've marked two lines. The outer line I've traced off the existing side panel. Now I've expanded the window and also the ventilation area in the existing side panel. You can see that I'm cutting on the inner line, and this is because I'm going to mount the mesh and the window onto the new side panel instead of the existing side panel. This means that the front and back of the side panels are going to be a lot flatter. So I'm now cutting out the ventilation area, and I almost always go for curved corners with side panels because it's a massive improvement in aesthetics. It is a little bit more difficult, but it's definitely worth it. You can use anything that is round that's the correct size to trace out your curves. In this case, I used a Dremel blade, and no matter what power tool you use to cut your curves, unless you're confident, don't go right out to your lines, because even the slightest mistake with curved corners and you will see it from a mile away. Leave plenty of metal behind. You can get that with a file. I always spend a lot of time filing. You can get incredible accuracy with a file. To give you an idea, I spent over an hour filing this panel, and almost all of that time was spent on perfecting the curves. You need to continue looking at the panel from different sides and different angles. That way you can see if there's a problem with the curves, if they don't match. This is what the panels are going to look like from the inside. This is how they're going to be mounted, and you might be able to see now what I mean by the window and the mesh is going to be mounted onto the new side panel. It's actually going to sit down inside the existing side panel. I'm now sanding the new panel. The main reason I'm doing this is just to knock off the rough spots from around the edges and from around the holes that I've drilled. It's bare aluminium, so it doesn't need much surface prep before painting. I'm now going to work on the rear side panel, and what I'm doing to the rear side panel is a little bit different to what I'm doing to the windowed side panel. Instead of making a new panel to cover the entire existing panel, I'm just going to make a panel to cover part of it. I've completed both of the panels, and I've also finished the painting. I live in an extremely hot and humid climate, and currently it's the most hot and humid time of year. Depending on the paint you are using and the technique you are using to paint, sometimes high temperatures and high humidity can affect the quality of the finish. Now I'm very happy with the finish, with the aesthetics, but the paint took about 6 times longer to dry than it was supposed to, and it's still not completely dry, so I'm concerned about the durability of the finish. This is a problem that I've come across a number of times previously, but only at this time of year. Most of you will know that I do all of my mods myself, but I'm actually going to send these panels off to be powder coated. It was going to take 2 weeks to get the paint stripped and the panels powder coated, whereas it's only going to take 3 days to get bare aluminium powder coated. So instead of making the client wait, I'm actually going to build these panels again from scratch. I've finished building the panels again, and I'm now doing a test fit. The panels are currently quite rough because I haven't yet done much surface prep. You can see a lot of bolt heads are visible. These are black M4 button head Allen key bolts. This is the way I wanted things, and also keep in mind that once the side panels are painted, the bolts are going to blend in a whole lot more. I currently have all of the bolts in position, also for the window and the mesh. This is because I wanted to see how it looked, and also I've had a bit of trouble placing the bolts so that the back side of them isn't in the way. They end up hitting parts of the case on the back side of the side panel. Looking at the rear side panel, you can see how small the new panel actually is. It covers less than a third of the rear side panel. It gives a very different look to the windowed side panel. Anyway, both of the panels fit, so they're now off to be powder coated. The side panels are back from the powder coaters, and I ended up getting all 4 of the panels powder coated. The original panels and the new panels, that way they all match up. The finish is satin black, and I went for this finish for a number of different reasons. First of all, I wanted a finish that was somewhere between the high gloss finishes of the front panel mod, the reservoirs, the tubing, the fans, and the stock finish of the TJ11, which is a textured matte finish. So this is a satin black, and satin is between matte and gloss, so it balances it out nicely. Also, this was an excellent opportunity to give the case a completely different look. Because the side panels make up most of the surface area of the case, if you change the finish of the side panels, it completely changes the look of the case. And even at a glance now, you can see that this case has been heavily modified, and it really is starting to not look much like the TJ11. It looks very different. The rear side panel is a better example of the finish. It looks a lot more glossy on the camera than it actually is. It's actually a lightly textured finish. The camera's not picking up the texture. You can see how clean the rear side panel looks now. I'm just so glad that I got all 4 of the side panels powder coated. Otherwise, you'd be able to see the massive difference between the 2 finishes. Anyway, now I just need to install the window and the mesh, and the side panel mods will be almost complete. Now I'm going to go back to work on the reinforcing for the water cooling loops. So I've been working on the reinforcing for the loops throughout a number of parts of the build log, and this is because it's something that is not really urgent. It can really be done at any time. I've completed the reinforcing for the CPU and motherboard loop. Now I just need to complete the reinforcing for the graphics loop. I've changed the design a number of times. I'm building it from the ground up. Obviously, there's really no rules with this kind of thing. I just need something that is going to hold the tubing in position, that's going to be strong enough, and that has decent aesthetics. So this is the final design. I've finished the shaping and the polishing. The polishing took nearly 3 hours. So you can see that I'm going to use a single UN mount. I was actually going to use 2 previously. I was also going to use an aluminium plate that was going to sit just underneath the expansion slot covers. That's not going to be necessary. I can bolt it directly to the expansion slot covers. Strength is not going to be a problem. If you think about the weight that this actually needs to hold, it's very minimal. The loops are almost self-supporting. This is almost not even necessary. So it's in position and it's complete, and I decided to use some neoprene between the acrylic and the fittings just to hold it in position better. Otherwise, having those 2 hard materials in contact with each other, it just moves around no matter how tight it is. So you can see how I've bolted it to the expansion slot covers, and strength is definitely not a problem. I can actually push the build over from the part of the loop that was previously the weakest part of the loop, the upper tube that you can see there. Now, I mentioned previously that I was going to make a feature out of the reinforcing. I've decided against that because it's here for practical purposes, and smoked acrylic is a material that blends into the background nicely. I also mentioned that I was going to go for organic shapes, and I did for the reinforcing for the CPU and motherboard loop, but I only did that because it was in a tight spot, so I had to cut away as much of the material as possible so that it would fit. So I ended up with curves. As you can see, there's plenty of room around the reinforcing for the graphics loop. It's also close to the EKFC bridge, so I thought I'd match up the aesthetics with the FC bridge as much as possible. So the reinforcing for the water cooling loops is now complete. I'm now going to go back to work on the side panel mods. I've installed the side panel window and the mesh, so the side panel mods are almost complete. There is just one more thing that needs to be done, which I'll talk about shortly. The side panel window I cut out with a jigsaw. I then went around and cleaned up the edges with a coarse grit sandpaper and worked my way back to a fine grit sandpaper so that the edges were polished. I needed to be extremely accurate with my measurements with the side panel window because it needed to fit inside the original side panel. Usually you have a little bit of leeway with the measurements with side panel windows because as long as they have 5 to 10 millimeters of overlap, it's enough. The mesh I cut out with tin snips. I then went around the edges with some side cutters and cut off the sharp edges. I also used a pair of side cutters to cut small holes in the mesh for the bolts. My main objective when modding these side panels was actually to make as much of the water cooling loops visible as possible. The stock window in the TJ11 is quite small and it would have blocked off the view to a lot of the graphics loop. I also wanted to make sure that the mid-plate radiator was visible because that was one of the major mods of this build, removing the ducts and the 180mm fans and replacing them with a radiator. That also meant that I needed to install the 2 blanking plates, so I really wanted to make sure that mod was fully visible through the side panel window. You can see that even the lower part of the CPU and motherboard loop is visible through the side panel mesh. It's also visible from around the back of the build. And this is actually another reason I use this large perforation mesh. I mentioned previously that I decided on this mesh because it gives the side panels an industrial look which suits the theme. But it's also because I wanted all of the components visible in the bottom compartment. And a lot of this is the cable management. Now, I was actually going to install a window in the rear side panel so that the cable management was visible, because I put so much effort into custom cables and cable management in this build that there was no way I wanted to hide it. But it ended up that the large perforation mesh was enough. It's fairly dark down in there now, except for the Bits Power X station, which lights up nicely. But all of the wiring down there is visible. So now looking at the insides of the side panels. So first of all, you can see the two holes that I've covered up. You can see that the window and the mesh is sitting down inside the original panel. So it's basically countersunk. The mesh is actually exactly the same height as the original panel, so it's flush. The window is slightly higher, probably about 1 millimeter. Now I've actually managed to hide most of the nuts underneath the side panel mounts. So you can see one of them just under there, and the rest of them are hidden completely underneath. You can't see them unless you remove the mounts. There's also another one you can see over here. I managed to hide about half of them like that. So I basically had to bolt everything on. I removed all of the original threads. Originally, the side panel window was mounted on the outside of the side panel, and it had threads in the side panel. The mesh had threads on the inside, but I cut all of those out. Now, some of you have probably noticed by now that the one thing I haven't yet installed into the build is dust filters. When you see dust filters in a build, they almost always stand out, and you know they're there for practical reasons. In a system like this that is all about aesthetics, that has been heavily modified, dust filters need to blend in. They need to look like part of the mods. They can't just be slapped on as an afterthought and stand out. So I do have a design, but unfortunately the material that I want to use I ordered about 3 weeks ago. It's going to take another couple of weeks to arrive. So instead of delaying the build and the next video, I'm going to go ahead and finish the build and ship it. And I'm going to ship the dust filters later separately, and everything that is required to install them. So this is my dust filter design for this build. The first thing you need to do when installing dust filters is look at your thermal design. I've covered the thermal design of this build previously. Basically, all of the fans on all of the radiators are drawing air from the bottom compartment. So there's massive positive pressure in the main compartment of the case, and all of the air is rising out of the top. So obviously where all of the air is being drawn from, that's where the dust filters need to be installed. So really this entire bottom compartment needs to be dust filtered. I'm actually only going to dust filter the side panel mesh. I'm not going to dust filter this rear panel because it's almost completely blocked off by the power supply, the radiator and tubing and wiring, and it only makes up a very small surface area. Most of the air is going to be coming in through the side panel mesh. Remember, the power supply is also drawing air from the bottom compartment, creating even more negative pressure. So what I'm going to use is 2 pieces of 3mm wide, 5mm high aluminium U channel. So 2 pieces per side panel. And I'm going to bolt it on the top and bottom of the mesh. So each piece is going to be bolted in 3 places. And it's actually going to help to hold the mesh a little bit flatter, so that works out well. Then I'm going to use dust filter foam, the type you can buy in large amounts and cut to size, and that's going to sit in the U channel at the top and bottom. So the U channel will hold it into position, and it will be perfectly serviceable. You can remove it to clean it and wash it and easily reinstall it. So this is similar to the dust filter foam I'm going to use, although what I'm going to use is a lot more dense. A lot of dust can still get in through this particular foam. And this particular foam also doesn't stand up very well. It would probably still get sucked through the fans. So that's how it's going to sit, and it's obviously going to be a long piece that goes all the way from one side to the other. So besides the final little addition of the dust filters, Cytotoxic is complete. If you want to see the dust filters, check out the link in the video description to my Facebook page. I'm going to post some photos there sometime after this video goes live. So now moving on to the test results, and I'm going to start with the temperature results. The client requested an overclock for this system. Obviously I can't go too crazy with overclocks for client builds because they need to run perfectly for years on end without any problems. So I took the CPU to 4.6 GHz, 1.4 volts. The memory to its XMP profile of 1600 MHz, 99924, 1.5 volts. I didn't end up overclocking the graphics cards because I find that often the GTX 680 is a weak overclocker, and the more graphics cards you have, the less they will overclock. I did actually have them up 100 MHz on both the core and memory, but performance gains were minimal and it was difficult to find stability. This is how my temperature testing works. For all of this testing, I've adjusted the ambient temperature to 20 degrees Celsius. All of the results are in degrees Celsius. For the idle test, I cold boot the system and let it idle for 30 minutes. I do this for both the CPU and graphics cards. For the load test, for the CPU, I use Prime 95 Small FFT for 30 minutes. For the graphics cards, I use the Unigine Heaven benchmark for 30 minutes. So first of all, the CPU results. At idle, at stock clocks, 28 degrees at a coolant temperature of 24 degrees. At idle, overclocked, 31 degrees at a coolant temperature of 25 degrees. At load, at stock clocks, 52 degrees at a coolant temperature of 27 degrees. At load, overclocked, 59 degrees at a coolant temperature of 29 degrees. Now for the graphics card results. At idle, 25 degrees at a coolant temperature of 25 degrees. At load, 41 degrees at a coolant temperature of 32 degrees. I didn't see the motherboard or PCH temperatures go over 31 degrees during all of this testing. Now moving on to the noise output results. Now I used to record the noise output, but that's obviously extremely inaccurate. I do have a decibel meter, but that won't even pick up a result for this system because it's so incredibly silent. There isn't a single component in this build rated at a noise output over 20 decibels except for the power supply, which is rated at 25 decibels, but only at maximum load. So most of the time the fan isn't even spinning. To give you a general idea, I can just hear the system over normal background noise when standing 1 meter away from it. Now moving on to the power consumption results. At idle, around 230 watts. The maximum power consumption I could get when the system was overclocked at full load was around 950 watts. Now moving on to the performance results, I'm going to show these in screenshots, and I'm going to compare the stock clock results to the overclocked results. So that concludes the test results. Some great results. The temperature results were pretty much as I expected. The water cooling loops are overkill for the components in this build. They have massive radiator capacity. The performance results, I actually managed to achieve nearly 70,000 in 3D Mark Vantage, which is one of my highest scores ever. That was when I had the CPU overclocked to 4.8 GHz and the graphics cards overclocked. That was when I was doing my initial overclocking. It's been a while since I've gone for any records, but I was happy to see such a high score out of this system. The final SSD results there were for the OCZ Vertex 4s in RAID 0. I've had a lot of fun building Cytotoxic. I can tell you that most of the time and effort with modding actually goes into coming up with ideas and designs. Once you have a good design, carrying it out, building it, is the easy part. It does require a lot of time and patience sometimes, custom wiring for example, but that's all part of the fun, and when it's finished, it is certainly all worth it. I have plenty more coming up. I actually have 2 more build logs starting straight after this one for client builds 9 and 10. I'm also doing a video on how I pack up my systems for shipping, and I'm going to show how I pack up Cytotoxic for shipping. So that sums up this build log. I hope you've enjoyed it. Thanks for watching. Please subscribe, like and favorite if you want to see more.